planets form naturally around stars. Astronomers have already discovered thousands of them using telescopes like the Kepler Space Telescope, and many of those planets sit in regions where temperatures might allow liquid water to exist. Given enough time and the right conditions, chemistry can turn into biology, and biology can eventually turn into intelligence. So here is the puzzle. If the universe is so vast, and if planets are so common, and if life can arise under the right circumstances, then intelligent civilizations should not be rare. In fact, there should be many of them, perhaps millions scattered throughout the cosmos. And yet when we look up at the sky, we hear nothing. No alien signals. No unmistakable spacecraft crossing between the stars. No clear evidence that another technological civilization has ever visited our solar system. The universe appears strangely quiet, almost as if nobody else is out there at all. This mystery is known as the Fermi Paradox, famously summarized by the physicist Enrico Fermi with a simple question: where is everybody? Tonight, we're going to explore that question in the spirit of curiosity and skepticism that someone like Richard Feynman loved, because sometimes the most interesting scientific mysteries aren't about what we see in the universe, but about what we don't see. When we begin thinking about the possibility of life beyond Earth, the first thing we must consider is the sheer size of the universe. Human intuition is not very good at understanding extremely large numbers, but astronomy forces us to confront them. Our home galaxy, the Milky Way, is already unimaginably vast. It contains somewhere between 100 billion and 400 billion stars, each one a massive ball of burning gas that could potentially host planets orbiting around it. For a long time, scientists did not even know whether planets around other stars were common or rare. Before the 1990s, we had never confirmed the existence of a single planet beyond our solar system. Many people wondered if our planetary system might be unusual, perhaps even unique. But modern astronomy changed that view dramatically. With the help of powerful observatories, such as the Kepler Space Telescope, astronomers began detecting thousands of planets orbiting distant stars. These discoveries revealed something remarkable. Planets are not rare accidents. They appear to form naturally as part of the normal process of star formation. When clouds of gas collapse to form a star, leftover material often gathers into disks that eventually form planets, moons, and other objects. In other words, wherever stars exist, planets are likely to exist as well. That realization dramatically increases the number of possible homes for life in the universe. If even a small fraction of those billions of stars in our galaxy have planets, and if only a tiny fraction of those planets have conditions suitable for life, the number of potentially habitable worlds could still be enormous. Astronomers paid particular attention to planets located in what is called the habitable zone around a star. This is the region where temperatures might allow liquid water to exist on a planet's surface. Water is important because it plays a key role in the chemistry of life as we know it. On Earth, every living organism depends on water in some form. When scientists study distant planetary systems, they often search for worlds that are roughly similar in size to Earth and located within this habitable zone. Over the past decade, researchers have identified many candidates that could potentially support environments where life might develop. But even if life begins somewhere, that does not automatically mean intelligent life will appear. Life on Earth started very early in our planet's history, perhaps only a few 100 million years after the planet formed. Yet complex multicellular life took billions of years to evolve. Intelligent creatures capable of building technology appeared only very recently on the cosmic timeline. Still, the enormous number of stars and planets suggests that this process might have happened more than once. Given enough time and enough planets, evolution might produce intelligent species in many places across the galaxy. And our galaxy is just one among many. Beyond the Milky Way lies a universe filled with countless other galaxies, each containing billions or even trillions of stars. One of our closest large galactic neighbors is the Andromeda Galaxy, which itself contains roughly 1 trillion stars. Multiply that by the hundreds of billions of galaxies scattered throughout the observable universe, and the number of potential worlds becomes almost impossible to comprehend. When scientists attempt to estimate how many technological civilizations might exist in our galaxy, they often use an idea known as the Drake equation, originally proposed by astronomer Frank Drake. The equation does not give a precise answer, but it helps scientists think systematically about the factors that might influence how often intelligent life arises. Some of those factors include how frequently stars form, how many planets orbit those stars, how often life appears on suitable planets, and how likely it is for intelligent species to develop advanced technology. When even modest estimates are inserted into the equation, the result often suggests that our galaxy could host many civilizations capable of communication or exploration. So when we look up at the night sky, we are not simply seeing distant stars. We are looking at an enormous collection of possible world sets, many of which may have their own histories, oceans, atmospheres, and perhaps even living organisms evolving under alien suns across the vast and silent expanse of the cosmos, where billions of stars shine within our galaxy alone while countless other galaxies stretch out, creating a universe so large that it seems almost inevitable that life could have appeared many times beyond the small blue planet we call home. Once we begin to appreciate how enormous the universe is and how many planets might exist, a very natural question begins to emerge. If life can appear on suitable planets, and if intelligent civilizations can develop technology, then why don't we see any evidence of them? Why does the universe appear so quiet? This puzzle is famously known as the Fermi Paradox. The paradox takes its name from the physicist Enrico Fermi, who raised a simple but powerful question during a casual conversation with colleagues in the 1950s. After discussing the possibility of extraterrestrial civilizations, Fermi reportedly asked, "Where is everybody?" It sounds like a simple question, but it contains a deep contradiction. On one hand, the numbers strongly suggest that intelligent life should not be extremely rare. Our galaxy, the Milky Way, contains hundreds of billions of stars. Many of those stars are billions of years older than our Sun, which means any civilizations that formed around them could have had a massive head start compared with humanity. If even a tiny fraction of those stars host planets where life emerges and eventually develops advanced technology, there could be thousands or even millions of civilizations scattered across the galaxy. Now consider how long the galaxy has existed. The Milky Way is more than 13 billion years old. Human technological civilization, by contrast, is only a few hundred years old if we measure it by our ability to send radio signals into space. That means if other intelligent species evolved millions of years earlier than we did, they could have developed technologies far beyond our imagination. In that case, one might expect at least some evidence of their presence. Perhaps we would detect powerful radio transmissions crossing interstellar space. Perhaps we would observe enormous engineering projects built around distant stars. Some scientists have even speculated about structures known as Dyson sphere, proposed by physicist Freeman Dyson, which would allow an advanced civilization to capture a large portion of a star's energy. Yet despite decades of searching, astronomers have not found clear evidence of such megastructures or unmistakable artificial signals from distant stars. Scientists have also conducted extensive searches for radio signals that might be produced by extraterrestrial technology. One of the most famous scientific efforts in this area is the work of the SETI Institute. Researchers involved in SETI use powerful radio telescopes to scan the sky for unusual signals that might originate from intelligent sources rather than natural cosmic processes. So far, the results have been intriguing, but inconclusive. Occasionally unusual signals appear, but they almost always turn out to have natural explanations or cannot be confirmed again. The mystery becomes even more puzzling when we consider the possibility of interstellar travel. While traveling between stars is extremely difficult, it is not completely forbidden by the laws of physics. A sufficiently advanced civilization might eventually develop spacecraft capable of exploring nearby star systems over long periods of time. Even slow exploration could gradually spread a civilization across the galaxy. If a species developed interstellar travel millions of years ago, it might have had plenty of time to expand across large portions of the Milky Way. Yet when we observe our solar system, we see no obvious signs that anyone else has ever been here. No alien probes orbiting our planet. No ancient technological artifacts on the moon. No clear evidence that an advanced civilization has visited or colonized our region of space. This silence creates the heart of the paradox. The universe appears large enough and old enough for intelligent life to arise many times, yet the sky remains strangely quiet. Physicists and astronomers have proposed many possible explanations. Perhaps intelligent life is extremely rare and Earth is unusual. Perhaps technological civilizations tend to destroy themselves before spreading across the galaxy. Perhaps interstellar travel is so difficult that even advanced species rarely attempt it. Or perhaps civilizations exist, but communicate in ways we do not yet understand. The question that began with a casual remark by Enrico Fermi continues to challenge scientists today, forcing us to confront a profound mystery about our place in a universe filled with assets. Tars yet strangely silent when we search for signs of other minds, looking back across the darkness of space. Once scientists recognized the strange silence of the universe, many different explanations began to emerge. The puzzle raised by the Fermi Paradox does not necessarily mean that extraterrestrial civilizations do not exist. Instead, it forces us to ask what factors might prevent us from detecting them. One possibility is that intelligent life itself might be extremely rare. Life on Earth appeared relatively early in our planet's history, but the path from simple microbes to intelligent beings capable of building technology took billions of years. For most of Earth's history, life existed only in very simple forms, such as bacteria and single-celled organisms. Complex animals appeared much later, and technological intelligence appeared only very recently. This suggests that the evolution of intelligence might require a long chain of unlikely events. If any one of those steps is extremely rare, then advanced civilizations could be far less common than we expect. Another idea is that technological civilizations might not last very long. Humanity has developed powerful technologies in only a few centuries, but those same technologies also create risks. Nuclear weapons, environmental damage, and artificial systems beyond our control could threaten the long-term survival of a civilization. Some scientists speculate about a stage known as the Great Filter, a point in the development of life where many civilizations fail to survive long enough to explore the galaxy. If most intelligent species eventually destroy themselves or collapse before achieving large-scale interstellar exploration, the galaxy could remain mostly silent even if life arises frequently. There is also the possibility that advanced civilizations deliberately avoid making themselves visible. A highly developed species might choose to remain quiet for safety or ethical reasons. Broadcasting powerful signals into space could reveal their location to unknown civilizations whose intentions are impossible to predict. Some thinkers compare this idea to animals in a forest moving quietly to avoid predators. In a similar way, intelligent species might limit their signals and remain difficult to detect. The universe could contain many civilizations that are simply cautious about announcing their presence. Another explanation is that communication itself may be more difficult than we assume. Humanity currently searches for radio signals because radio waves travel efficiently through space. Organizations such as the SETI Institute use radio telescopes to scan the sky for patterns that might indicate artificial transmissions. But alien civilizations might not use radio technology at all. They could communicate using methods we have not yet discovered, or technologies that operate in ways completely unfamiliar to us. If that is the case, our searches might simply be looking in the wrong place. Distance is also a major factor. Even within our own galaxy, stars are separated by enormous distances. Signals weaken as they spread outward, and interstellar communication might require enormous amounts of energy to remain detectable across thousands of light years. And then there is the perspective encouraged by physicists like Richard Feynman, who often reminded people that the universe does not have to match our expectations. Science progresses by carefully observing nature and questioning our assumptions. If the universe appears silent, it may be telling us something important about how life develops, how civilizations behave, or how difficult it is to spread across the stars. Feynman loved the idea that unanswered questions are not failures of science, but opportunities to learn more about reality. The mystery of cosmic silence may simply reflect how little we still know about the processes that shape life and intelligence on a cosmic scale. When we look out into the vast star fields of the Milky Way, we are confronted with a universe filled with possibilities, yet strangely quiet. That silence may hide countless civilizations beyond our current reach, or it may reveal that intelligent life is one of the rarest phenomena in the cosmos. Leaving humanity alone, for now in a galaxy of billions of stars, where the question of who else might be out there remains one of the most fascinating mysteries science has ever tried to understand. So the next time you look up at the night sky, remember that the silence we hear may be just as important as the stars we see. The mystery behind the Fermi Paradox reminds us that the universe is still full of unanswered questions. In a galaxy as vast as the Milky Way, it seems almost impossible that Earth is the only place where intelligence has appeared. Yet so far, the cosmos remains quiet. Perhaps civilizations are rare. Perhaps they are far away. Or perhaps they are far away. Or perhaps we simply haven't learned how to listen properly yet. As physicists like Richard Feynman often suggested, the beauty of science lies in asking bold questions and being curious enough to keep searching for the answers.